Calculus examples, the chain rule. This is video 20. In example 6, y equals x cubed e to the minus 2x. To review the above videos, you should pause this video now. All videos have been written and produced by Michael J. Bankhead. The product rule, using the terms first function and second function. The product rule finds the derivative of a function of the form y equals f of x times g of x. The most important form of the product rule is shown below. Call this equation equation 1. Since f of x is the first function and g of x is the second function, equation 1 can be written in words using these phrases. This is shown below. Y dash of x equals g of x, where g of x is the second function, so substitute the second function times d by dx of f of x, where f of x is the first function, so substitute the derivative of the first function, plus f of x, where f of x is the first function, so substitute the first function, times d by dx of g of x, where g of x is the second function, so substitute the derivative of the second function. Call this equation equation 2. Note that if you want to find the derivative of the function s equals f of t times g of t using equation 2, you must replace y dash of x with s dash of t, but the right-hand side of equation 2 remains the same. The function f of t is the first function, and the function g of t is the second function. To review the verbal form of the product rule, you should pause this video now. Example 6. Find the derivative of the function y equals x cubed e to the minus 2x. Solution. 1. Finding the derivative. The function y equals x cubed e to the minus 2x is the product of two separate functions. the first function is x cubed, and the second function is e to the minus 2x. So the derivative of y must be found using the product rule. The verbal form of the product rule is shown below, followed by the derivative of y. Reminder: y dash of x equals the second function, which is e to the minus 2x, so substitute e to the minus 2x times the derivative of the first function is the derivative of x cubed, which is 3x squared, plus the first function, which is x cubed, so substitute x cubed times the derivative of the second function, which is the derivative of e to the minus 2x, which is minus 2e to the minus 2x. Thus, after applying the product rule, y dash of x equals e to the minus 2x, 3x squared, plus x cubed minus 2e to the minus 2x. Call this equation equation 3. Just a few weeks after I had finished teaching the product rule, an increasing number of my students would find the derivative of a product using the verbal form of the product rule. Their solution would start with the equivalent of equation 3 obtained directly from the question on the test. If they actually stated that they used the product rule, I gave them a bonus mark. To review the above working, you should pause this video now. 2. Simplifying the derivative. If the derivative can be simplified, then it must be simplified. From equation 3 in scene 3, the derivative is equals. Move 3x squared in front of e to the minus 2x. 3x squared e to the minus 2x plus bring down x cubed times minus 2e to the minus 2x equals bring down 3x squared e to the minus 2x. Put the minus with the plus to form a minus. Move 2 to the front of the term. 2. Bring down x cubed times bring down e to the minus 2x equals separate out x squared e to the minus 2x from each term. 3x squared e to the minus 2x becomes 3 times x squared e to the minus 2x minus 2x cubed e to the minus 2x becomes 2x times x squared e to the minus 2x equals, factor out x squared e to the minus 2x from each term, giving x squared e to the minus 2x times 3 minus 2x is 3 minus 2x. Final statement. The derivative of the function y equals x cubed e to the minus 2x is y dash of x equals x squared e to the minus 2x times 3 minus 2x. This answer can also be written as y dash of x equals minus x squared e to the minus 2x times 2x minus 3. In this answer, the terms in the polynomial are in the correct order. To review the above working, you should pause this video now. When solving questions from your textbook similar to the example in this video, you will find it helpful to display scene 3 to find the derivative, followed by scene 4 to simplify the derivative. You should then find this topic simple and beautiful. Cheers! Do not forget to check your answers with the answers in the back of the textbook. Reminder displayed without commentary. To review the above instructions and reminder, you should pause this video now.